Good morning, everyone. Hello, everyone. My name is Shrijan Shekhar, and I'm a student of Bangalore Institute of Technology. I'm from the CSE department, and today I'll be presenting you a PPT on behavioral model, which is one of the subtypes of VHDL modules. So, first of all, it is very important for us to understand what are VHDL modules before we dive into one of its subtypes details. So, I'll just like to tell you what they are. VHDL modules are also known as entities and architectures. It is a fundamental building block that is used to describe the structure and the behavior of any digital circuit. Let's take a comprehensive overview of what are VHDL modules. Entity, like I talked about. Entity is a declaration of the interface of a hardware component. It defines the inputs, outputs, and the other necessary signals required to interact with the component. It serves as the interface or the public part of the module. Architecture. Architecture describes the internal behavior of the circuit and the implementation of the entity. So basically, it's entity. We declare all the inputs, outputs, variables, and architecture basically determines how they're going to function, like what's the relation of the input with the output. It contains the concurrent statements, processors, and other constructs to define the functionality of the hardware that we're talking about. Port are the interface between the entity and its environment. They define the inputs and the outputs of the module. Ports can be different types such as input, output, or bidirectional, both input and output. Signals. Signals are used for internal communication within the module. They are declared within the architecture itself and can be used to store intermediate values or to control the behavior of the module. Concurrent statements. These are statements that execute concurrently, meaning they execute in parallel. Examples include signal assignments, conditional assignments, and concurrent procedures calls. Processes. Processes are sequential blocks of code that execute sequentially, that is, one after the other. They are used to model sequential behavior within a VHDL module. Processes can contain conditional statements, loops, and signal assignments. Generics. Generics are used to parameterize VHDL modules. They allow the user to customize the behavior and the configuration of a module by passing parameters at installation. Instantation. Instantation is the process of creating an instance of a module within another module. This allows for hierarchical design, whereas complex systems are built from smaller reusable components. Configuration. Configuration statements are used to specify which architecture of an entity should be used during simulation or synthesis. They allow for flexibility in selecting different implementations for a given entity. VHDL modules provide a powerful means of describing digital hardware at various levels of abstraction, facilitating modular design, reuse, and verification. As I've explained you what VHDL modules are, I'll give a comprehensive look out for VHDL modules as I've written here. VHDL module is a standardized notation used to model and stimulate electronic devices. It is used to represent various elements of a digital design, such as logic gate, flip-flops, multiplexers, counters, and more complex components such as processors and communication interfaces. It is basically the fundamental building block of a digital design and is described using VHDL language. So basically, there are three types of VHDL modules: data flow model, behavioral model, and structural model. And like I told you before, in today's PPT, we'll be talking about the behavioral model. It's what it does, what it basically focuses on, and what's its main purpose. Behavioral model. A behavioral model basically describes the functionality or behavior of a digital circuit without specifying its internal structure or implementation details. A behavioral model, instead of focusing on how a circuit is built, the way the data flows in the circuit, it basically focuses on how a circuit is constructed. It focuses on what a circuit does and how it behaves under certain conditions instead of focusing on the way it is built or the way the structure flows inside the behavioral model, inside It it typically uses concurrent statements. It typically uses concurrent statements to describe the operations of a digital circuits. These statements can use logic expression, conditional statements, loops, and other constructs to define the desired behavior of a circuit. Behavioral models are basically used in algorithm description, simulation, rapid prototyping, or design abstraction. So basically, a behavioral model in VHDL describes the functionality or behavior of a digital hardware component without specifying its internal structure. So, like I said before, it focuses on how the circuit is behaving instead of how the circuit is built. It focuses on defining what the hardware does rather than how it is implemented. Let's talk about a simplified breakdown of a behavioral model in VHDL. So first comes entity declaration. We first of all define the interface of the hardware component using the entity keyword. We declare the input and output ports to specify the external connections of the component. Architecture body. It implements the behavior of the component within the architecture block. Use concurrent statements or processes to describe its functionality. Behavioral assignments. So we use concurrent assignments to describe the desired behavior. Assign values to output signals based on the inputs or other conditions. Processes. Use processes for more complex behavior or sequential logic. Processes allow the use of conditional statements, loops, and signal assignments. Simulation and verification. Simulate the behavior model to verify its correctness and functionality. We use VHDL simulation tools to observe the behavior of the component and debug any issue. Parameterization. Well, this is an optional thing. We parameterize the behavioral model to make it more flexible and reusable. We use generics or constants to customize the behavior of the component. Documentation. Include comments and documentation to describe the purpose and functionality of the behavioral model. Good documentation improves the readability and maintainability of the model. Well, by following these guidelines, designers can create VHDL behavioral modules in VHDL to accurately represent the functionality of a digital hardware components. In the behavioral model, like I have explained you the structure, I'll just go through very quickly this slide. We use the always block to is used to realize the combination or sequential elements. Basically define the inputs and the outputs. Regular keyword is used to declare registers to store individual values. We use always at the rate A or B, trigger the change, A or B changes, and performs a particular operation described under its function. So basically, when we use this always at the rate bracket A or B, it trigger changes. It will always change when A or B changes. So basically, the output value is going to change when A or B go through any change and perform particular operation under the given function. If else case constructs are used to specify conditions. Like I said, we can in the previous slide I explained you what are the conditions can be specified in a behavioral module to get a certain output. We can specify certain conditions. For those specifying those conditions, we use the if-else case constructs to specify the conditions. Well, I'll now show you a program for the behavioral model. Well, this is a code for the AND gate, so I'll just and the code will run. Uh, Now, as I have described you how is a behave, I have completely told you what a behavioral model is and what it does and its structure and everything. We have to also understand an overview of how a behavioral model is a little different from the other two subtypes of a VHDL module, that is the data flow model and the structural module. So in this whole PPT, I spoke about how behavioral model, as we know, describes the behavior of the digital circuit and how it behaves under different conditions without necessarily taking in consideration the structure of the circuit or the flow of data in circuit. Whereas in case of a structural module, yes, so as I was telling that a behavioral model basically focuses on describing the behavior of a system or component. It typically describes how the system reacts to stimuli or inputs and how it transitions from one state to another, often represented using state diagrams, finite state machines, or behavioral programming languages like VHD or Verilog in hardware design. It emphasizes the dynamic aspects of the system, such as how it responds to events or changes in the environment. Whereas in case of the structural module, it focuses on describing the structure or the organization of a system. It typically describes the components of the system and their interconnections. It emphasizes on the static aspect of the system, such as its architecture, modules, classes, and relationships between them, represented using diagrams like UML class diagrams, entity relationships diagrams, or hardware description languages or digital circuits. Whereas, let's lastly, we will talk about the data flow model. It focuses on describing the flow of data within a system, typically describes how a data moves through the system from input or processing in output. It emphasizes on the transformation of data as it moves through different stages of processing inside the hardware design. And it is represented using data flow diagrams, process models, or flowcharts. In summary, if we talk, while all three models are used to understand the design system, they differ in what aspects of system they emphasize. The behavioral model focuses on the behavior of the component of the digital circuit. I would also like to discuss the uses of a behavioral model. Yes, so let's talk about some of the uses of the behavioral model. Behavioral models have several important uses in various fields, including computer science, engineering, psychology, and economics. Some of the key uses of behavioral model include soft system design and analysis. Behavioral models are used to design and analyze systems by describing their dynamic behavior in response to different stimuli or inputs. This helps engineers to understand how a system will function under various conditions and allows for refinement and optimization of system behavior. Software engineering. In software engineering, behavioral models are used to describe the behavior of software systems, including how they respond to other interactions and input data. This helps developers design software with several desired functionalities and performance characteristics. Hardware design. In hardware design, especially in digital systems, the behavioral models are used to describe the behavior of electronic circuits and systems. This includes specifying how digital components interact and how signals propagate through the system. Simulation and prototyping. Behavioral models are often used to stimulate the behavior of complex systems before they are built or implemented. This allows engineers to test different design alternatives, evaluate performances, and identify potential issues or bottlenecks. Predictive modeling. Behavioral models are used in fields such as economics and finance to predict human behavior and market trends by analyzing historical data and identifying patterns in behaviors. These models can forecast future outcomes and help make informed decisions. Psychology research. Behavioral models are used in psychology to understand and predict human behavior in various contexts. These models can help psychologists develop theories about how people think, feel, and behave, and test these theories through experimentation and observation. Game theory. In economics and game theory, behavioral models are used to study strategic interactions between rational agents. By modeling how individuals make decisions in competitive situations, researchers can analyze outcomes and predict behavior in complex systems. Overall, behavioral models play a crucial role in understanding and predicting the behavior of systems and individuals in a wide range of domains, enabling better decision making and problem solving. With this, we come to an end of our PPT. I hope this PPT helped you in understanding a better version of behavioral model, and I would just like to say thank you for your time.